Alright, so question 5 is a palindrome question. The idea is that you're looking at a word and you want to know whether the word reads the same from left or from the right. So for example, in this case, madam is a palindrome because you read from left, M-A-D-A-M, you read from the right, M-A-D-A-M, it's still the same. Okay, so now this is the algorithm that is offered, but essentially the basic concept is to match a word letter by letter. So in this case, let's say you have madam. Your I, okay, there is an index here. So your I is initially at 0, right? So your I is pointing here. Now it wants to find its twin. And what is the twin of I? The twin of I, it means that if you take I steps from the left, then you want to take the same number of steps from the right. So that's why you have this following expression, the length of S, the length of the whole string, minus 1, which is the last element, minus I. So you're moving from right to left. In this case, the twin of 0 is going to be 4. And then you check whether or not they're the same. If they are the same, then you can reduce it to the middle string by advancing the I such that I now points to the next one and this one now points to the second from the right. So in that case you can keep matching them as you go inward to the middle. And that essentially gets the reduction done by going from outside in. So then you take one letter at a time from the left and the right, and at any point of time, if they don't match, that means that it's not a palindrome. Otherwise, it's a palindrome and you can just keep moving. Alright? Now, the other way of doing this, but the same idea, but instead of passing in just the I, you can try to carve out the whole array. This is the so-called second algorithm. In this case, what you do is to take the string S, right? So we're going to compare whether the first letter is the same as the last one. Now if they're the same, then you carve a smaller subarray that is in the middle of that by slicing off the first one and the last one, and then check again whether it's still a palindrome. So meaning if you started out with madam, because the M and the M match, so then you slice off the M's, then you have Ada, ADA, and you check whether that is still a palindrome. And you check the A and the A, and you want to know whether it's still a palindrome, then you pass a D in, and slice 1 is always a palindrome. So in that case you return true. Now, the complexity of this, because as you go outside in, right, so essentially you're going to be making n over 2 comparisons. If the n is the length of the string, for each one you find its twin and compare them, so you're going to be making n over 2. So then the complexity is going to be O n. Alright, so that's question 5.